we are now going to show you the following example. It's an example where the initial displacement f of x is a piecewise defined function, and in the region when x is from 0 to pi over 2, it has the following description: 1 over pi multiplied with x. And similarly, in the rest of the interval from 0 to pi, that is from pi half to pi, f of x is equal to this expression. Moreover, c is equal to 1 and the initial velocity is equal to 0, so there is no initial velocity. This means that all these coefficients b and star is equal to 0. Just to recall, the definition of b and star is the integral involving g of x, and it's 0, so when the integrand is 0, we also have that all these coefficients are 0. However, the coefficient bn is described in this way generally, and in this case L is equal to pi, so therefore we can write this general expression in this form. Note that L is equal to pi, so we can simplify this guy in this way. Since the function f of x has two different descriptions in each of these intervals, we have to split the integral into two parts. So we take the integral from 0 to pi over 2 first, and then we take the integral from pi over 2 to pi. And we replace f of x with the description of f of x in the respective interval. So in this interval from 0 to pi half, we use this expression for f of x, as we can see from this definition, and in the interval from pi over 2 to pi, we use this expression for f of x, since we have this definition of f of x in this interval. So the next we have to do is to compute these two integrals. In order to compute these integrals, we have to use integration by parts, and it's very important that you students know how to integrate by parts. You use the blue identity here. This is a general identity for integration by parts. We integrate u times v prime and get u times v minus the integral of u prime times v. So then we only have to consider what should we call u and what should we call v. We choose to call u this, and we call v prime this, and then we, by simple manipulation, find that uv times v can be written like this. Just take the integral of sine nx, then we get minus cosine nx divided to n, and we see this n here. Then we take minus this guy, and it can be written like this. And in order to find the integral here, we just have to integrate once more, and then we get this expression. So now we have found the antiderivative of this integrand. Therefore we we do not use limits here, just to show that we are finding the primitive function of, or the antiderivative, if you like. So when we put on the limits 0 and pi over 2, it's very simple to just find the value of this integral. So we just put 0 and pi over 2 and put in the antiderivative of the function which we found here. And when we are doing this, replacing x with pi over 2, here, 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 then take minus the same expression just with x replaced by 0, we obtain this expression. So we do the same, very similar method finding the other integral. First we have to find the antiderivative of this guy. We use integration by parts in the same manner as we did for the first example, and by using this we obtain that the integral takes this value. Okay, if we now recall that Bn was 2 over pi multiplied with the sum of these two integrals, we just replace these two integrals which we wrote before with the values that we have found. And so when we do this, we find this simple expression for Bn. And Bn is 0 for all even values of n. Therefore it's enough to use values of this form, because when Bn is equal to 0 for all even values of n, we only have to use n values which are odd. And all odd numbers can be written in this way, 2k plus 1. So Bn is equal to b 2k plus n. We replace n by this and obtain this expression for each Bn.